Let's analyze this little object here that's got a bar and a cable that are holding up a 10 kilogram mass by drawing a free body diagram of it. So here's the joint where the mass, the bar, and the cable all come together. So we obviously are going to have a force up in this direction, force tension, we're going to call that, maybe string on weight. Then we're going to have another force here that's, I think, going to be a compressive force. And so I'm going to put it in this direction here. I'm going to call this just force of bar on weight. And then I'm going to have the weight of the weight itself here. So force of gravity, Earth on weight. Next thing I want to do is impose a coordinate axis system on this thing to aid my problem solving. So I'm going to call this horizontal, or just X, positive going to the right, and then I'll establish a vertical Y with positive going up. That's kind of the normal convention, unless it makes sense to do things otherwise. Now if I go to my drawing here, I realize that this is a 30-degree angle here if it's a 60-degree angle up at the top. So going to my free body diagram, that's 30 degrees right there. Now, to solve this problem, let's find a sum of forces in the x and the y axis. So first of all, let's do F. Sum of all forces in the x direction is going to be equal to, well, if positive is to the right, we're going to have all of force B on W here. B on W. And we are going to have part of the tension force. So minus force tension. But the part of the force tension that's going to be on the x-axis is going to be force tension times cosine of 30 degrees, because the x-axis component lies adjacent to the 30-degree angle. And if it's not in motion, that means the sum of all those forces is going to be equal to 0. Both of these, force BW and force tension, we don't know. So this is a single equation that has two unknowns, and it's unsolvable. So we have to look for another equation, and that other equation, of course, is going to be the sum of all forces in the y-axis. So if we sum all the forces in the y-axis, FBW is not a player there, but FT is. And it's the other component, FT sine of 30 degrees, that acts upwardly in the vertical axis. And gravity, FG, acts downward, and that sum is going to be equal to 0. So that means Ft times sine of 30 degrees is going to be equal to Fg. So that means Ft is going to be equal to Fg over the sine of 30 degrees. But Fg we know is 10 kilograms times 9.81 newtons per kilogram. So we'll divide that by sine of 30 degrees. The unit will be newtons. And the answer is 196 newtons. So now we can go back to our f of x and plug that in. So that 196 newtons, now that we've determined what that is, that can go in here for f of t. So sliding up here, that tells us that F, B on weight, is going to be equal to 196 newtons times the cosine of 30 degrees, which works out to 170 newtons. So now we know what both the tension and the compression on the bar are.